This is another example of a relative motion problem. So if I have the question, what direction does the airplane actually go? If we have an airplane that's pointed directly east and going, according to them, 80 meters per second compared to the air, but there's a wind blowing south, so this airplane is actually traveling in wind that's going south at 30 meters per second. What direction will the airplane actually go? Now, again, what direction does it go? Normally, things are relative to the surface of the Earth. So if it doesn't specifically say so, then relative to the Earth. So this wind is 30 meters per second relative to the Earth. What direction will it go relative to the Earth? This one is relative to the air. So again, this is the type of problem where we're going to use this V13 is V12 plus V23. So thing 3 can be the Earth. What we want is the airplane compared to as seen by the Earth. So we're going to call the airplane thing 1, and we'll call the wind thing 2. Okay, so V13, this is what we're looking for, is V12. So this is the velocity of thing 1, the airplane, as seen by thing 2, the air. So the velocity of the airplane as seen by the air, if you were sitting here in the air, the airplane is going 80 meters per second east. So 80 meters per second in the plus x direction, plus velocity of thing 2 is the wind, compared to the Earth. So 30 meters per second south. 30 meters per second y hat. So the velocity of the airplane, as seen by the Earth, is 80 meters per second east plus 30 meters per second south. Oh, sorry, I should have gotten a negative there. So this is velocity of the wind compared to the Earth, negative y. Or 80 meters per second east and 30 meters per second south. It's asking for direction. It didn't ask for this. So if I start here and I go 80 meters per second east, so there's 80 this way, and means plus, 30 meters per second south, so from here, tip to tail, 30 meters per second that way. So this is 30 meters per second, 80 meters per second. This is the actual path the airplane will go on. So what direction? This is the thing we're looking for. So that theta is what we're looking for. So our answer, we can use that inverse tangent of theta is opposite 30 meters per second over 80 meters per second. So that means theta equals 20.6 degrees, 30 over 80, and this is in the direction from east, it's going south. So south of east. That's the direction that the airplane's going. This 30 meters per second you could also look at as being a negative. Okay, so then if you put in a negative 30 here, then you would end up with a negative 20.6 degrees. So from this direction, negative would be that way. So instead of going north, it's going south. So then the south is another way of saying the negative from east. So 20.6 degrees south of east.